Hello everyone, Paul here from Fixing Foundations. I would like to welcome you to the second episode of this full course for college algebra. Today we're going to be going over some very basic principles in regards to graphing mapping coordinates onto a graph, as well as some basic principles regarding linear equations. And to start off this lesson, I would like to show you this diagram. Now here you can see that there's an x-axis and a y-axis. The x-axis goes from left to right, so it goes horizontally, and the y-axis goes up and down, so that is our vertical axis. And you can see here we also have quadrants 1, 2, 3, and 4. And we also have an origin in the middle. And the origin exists at 0.00, but what exactly does that mean? Well, let's say if I were to travel from the origin and I take one step here and then I take another step here and I stop right here. That would mean that this point right here would be 2, 0. Or if I were to go up, right? Say if I were to go up 3 steps, so I would go 1 step up here, another step here, and then a third step. And then I stopped at this point. Then this point would be 0, 3. That's not a really good looking 3, but hopefully you can tell. Okay, so this means that when we travel on the x-axis, the number we're going to change is going to be the number on the left, and then when you're traveling up and down, the number you're going to change is the number on the right. So I'll write that out here. So this is the format that we use. X, y. And this is known as an ordered pair. So down here we have 2, 0. This is an ordered pair. This is an ordered pair. And finally, this is an ordered pair. Because whenever we map an x-coordinate and a y-coordinate in parentheses like this, and we separate them as a comma with a comma, that is known as an ordered pair. Now, what if we tried to do something a little more complicated? Let's say we wanted to go a little further, right? Say we wanted to take, let's say, 1, 2, 3, 4, 5 steps to the right, and 1, 2, 3, 4, 5, 6 steps up, right? So 5 steps to the right and 6 steps up, that would fall here. And then this point would be 5, 6. So you could use more than one at any given time. And then we can also go left and we can go down. So let's say if we went left, so we're going to the negatives now. Keep that in mind. So left, -1, and then we go -2, and then we would go -3. And say we wanted to go down here on the y-axis. This would be -1, -2, and we'll stop here. So we'll go 3 steps to the left and then 2 steps down. we mark off this point. Well, this point would be -3, -2. And then it also can get confusing because sometimes you have to use both negative and positive numbers in your ordered pair. So here, because we were in quadrant 3, they were both negative. But let's say if we went 3 steps to the left, so we stopped here again at 3, and then we went 1 step up, so we went here. Well, this would be -3 and +1. Because going left on the x-axis yields a negative number, and then going up on the y will yield a positive number. And finally, let's say we went down to -1, -2. We stop here at -3. And then we go right. So we can go all the way from 1, 2, 3, 4, 5, and finally stop at 6. So we would be here. This point would be 6 and -3. Because that value is going to be negative because we went down on the y-axis. So, if this helps you, you could know that in the x-axis, both x and y are always positive, so it's going to be positive, positive. I meant to say quadrant 1. So in quadrant 1, it's going to be positive, positive. Quadrant 2 will be negative, positive, because going left will be negative on the x and going up will be positive on the y. Quadrant 3 will yield 2 negative numbers, and then quadrant 4 would give you a positive on the x and a negative on the y. Now I want to give some examples because in a previous video we touched on what a linear equation was. So let's write down an equation. We'll start with just an expression. So we'll say something like, we'll keep it very simple. We'll say x plus 1. And then we'll turn it into an equation, and on the left side we'll put y, and we'll put an equal sign to separate both of them. So we have the equation here, y equals x plus 1. Now, let's put some numbers in for x. So let's see what happens if we were to put 0 in for x. So we put y here, put an equal sign, we set x equal to 1. Actually, I said we'd do 0 first, so let's do 0. We would set x equal to 0. A lot of times when you substitute like this, when you drop in a number for a variable, you want to leave it in parentheses, but in this case it doesn't matter too much. So we would get 0 plus 1. This would yield 1. And then what we can do is we can write it here on the thing that I've drawn on the right, the table we have here. So we put 0 in for the x, so I'll leave a 0 here. And then because putting that into the equation yielded a 1 for the y, I'm going to put a 1 here. And you can see that we now have what we need to create an ordered pair. So if we come here to the graph, this would be the origin point right here. So this would be 0, 0. So we don't take any steps on the x. So we don't go right or left, but we go up one step because that's a positive y. And we stop here. This would give us the point 0, 1. And let's say we did another equation, right? We did y equals... say we substituted 1 in for x. Now we could put in 1 for the x, and then we add another 1 to it. This gives us 2. So putting this on our table, we would leave 1 here on the x side because that is what we substituted. And then we got 2, so we put 2 on the right. So we would take 1 step to the right, and then we would take 2 steps up, and we would stop here. And this would give us the ordered pair 1, 2. I'm gonna do one more in the positive, just so it's very, very clear. And this time I'm gonna substitute 2 in for x. So I'll drop in 2, 2 plus 1. This is going to give 3. So then, since we substituted 2, I'm going to put a 2 on this part of the table, and then I'll put a 3 on the other side. Drop it in here, because that is the next point. Then this is 2, 3. And we can do something else, too. We can also use negative numbers, and that can get a little tricky, but we'll take it slow. So I'll erase everything I have here so far, just to clean up a bit. And then we take same equation, so it would be y equals x plus 1. And then we put a negative 1 in for x, so y equals negative 1 for the x plus 1. This gives us 0, because negative 1 plus 1 equals 0. So, careful not to get confused here. I'm going to take what I've written here on this table, I'm going to move it down a bit, just so that it's very clear where the negative is going to fall. Let's move this down a little bit. Move the other one down too. All right. Okay, a little piece of the 1 stayed there. Try to get that down. There we go. And then we put a negative 1 here for the x. And then 0 for the y, because we substituted negative 1 and then we got a 0 as our output for the y. Well, that would fall here. So we would take 1 step to the left, and then we wouldn't take any steps up or down because y is 0, and then that point falls here. And this is negative 1, 0. And then we could do something else. We can actually create the linear equation. So because we've said that this is a linear equation, it basically means that it's going to look like a line. And then we can draw a line to help us better understand how the relationship that exists between these numbers. So it would go this way, and then it would even go the same way into the negatives. And it looks like a straight line. So when you have equations that look like this, that is the way they are going to look on the graph. Now, I want to show you another example. And in this case, I'm actually going to add a coefficient to the expression. So let me show you what that would look like. I'm going to do y equals 2x minus 1. So this is the new equation that we'll use. Well, let's just get a few points in here. We'll start with 0. 0 is usually a good number to start with. So y equals 2, we'll substitute 0 in for the x, and then we'll subtract by 1. So because we're simplifying this expression, first thing we're going to do is multiply 2 and 0. Well, that's going to give us 0. And then we're going to subtract by 1, and we're going to get the answer, negative 1, as the y. So we go back here to our table. I'm going to leave a little bit of space on the top, but I'm going to put the 0 here, because that is what we put in for the x, and then we got a negative 1 for the y. And then starting from the origin, so this would be 0, 0, right here in the middle. And then we take one step down, so we stop here. We don't move left or right because x is 0. So we stop here. Well, this point is going to be 0, negative 1. That is the ordered pair that describes where that coordinate falls. Let's do another one. Let's do y equals 2, and then we'll substitute 1 in for x. And then we'll solve this equation. So y, we simplify this. This is going to give us 2, because 2 times 1 equals 2. Subtract by 1, and finally, we get 1. So putting this on the graph, we put 1 in for the x, because that is what we substituted, and then we put 1 in for the y as well, because that is also what we got as our output. And where is that going to fall? Well, it's 1, 1. They're both positive, so we take one step to the right and then one step up. That falls here. And this ordered pair is going to be 1, 1. Now, I want to make something clear, right? So I'm going to go back to the previous example for a moment that we used. So these points on the graph, right, these were kind of like what we were doing when we first started. So this would be 1, this would be 2, this would be 3, and that wouldn't be 3 again. I apologize. That would be 4. And then going up, it would be, 1, 2, 3, and 4. And then if we were to go down, it would be negatives. So negative 1, negative 2, and then going left, it would be negative 1, negative 2. But we could have used another increment. So I'll do a rough sketch of a graph here. We could have done something like, we could have had this graph, and then we could have had it go by 2s. So we could have done 2, 4, 6, 2, 4, 6, and then we would have went that way in the negatives as well. So negative 2, negative 4, negative 6, and then, negative 2, negative 4, negative 6. And then we would have had to account for that. And that can get a little confusing, and more confusing still sometimes. And I don't think this happens a lot. I'm going to draw it here. I'm going to erase the equation for a moment. So sometimes it could be something like this. So you can have steps like this, like positive 1, positive 2, positive 3. But going up, it can be like 100, 200, and 300. So keep this in mind. This can be very disorienting if you're not being very careful about what the graph is displaying to you. So just keep this in mind when you work with these graphs. This is a little more advanced, but I just want to let you know this in case this comes up in class or something that you have a sense that this could happen. So always pay very close attention to what increments the numbers on the x and the y are increasing and decreasing at. Now back to our current example. So let's say we were to supplement something else for x. We were to put another number in for x. Say if we did, I'll erase this stuff. Let's try 2. I want to show you what 2 looks like, and then after that we'll try a negative number. So let's put 2 in for x. So 2, we substitute 2, and then we subtract by 1. So this is going to give us 4, because 2 times 2 equals 4. And we subtract by 1. That is going to give you a 3. So we write that down on our coordinate plane. We substituted 2 for the x. So we put 2 down there. And then we're going to put 3 down for the y, because that is what we got. Well, to map that, so we take 2 steps to the right, and then we take 3 steps up. So 1, 2, 3. We would fall here. This is where it would fall. And then we get the answer 2, positive 2, and positive 3. And finally, we'll try a negative, just to get you comfortable with that, because that will come up. So we'll try y equals 2, negative 1, drop that in for x, subtracted by 1. Now, keep in mind that a positive number and a negative number create a negative number, so we are going to be at negative 2. We're going to subtract that by 1. And finally, we're going to get negative 3 for the y. So I'll put it up here. We put a negative 1 for the x, and then we got a negative 3 for the y. So we take 1 step to the left, because now we're going into the negatives, so we want to go left and down, because both are negative. So we take 1 step to the left and 3 steps down. 1, 2, 3. That falls right here. And this is going to give you negative 1 and negative 3. And then now we definitely have enough information to draw what the linear equation would look like, right? So we're going to start down here. This was our first point, 0, negative 1. I don't want to start at the origin. I'm going to create a line. It's going to connect all the points. It's not a perfect line, but you should be able to see the picture. And there we go. So that is our linear equation. And if you look carefully, it is actually steeper than the one we had before. This one was, I don't want to say flat. It's not as steep. This is a much steeper linear equation. And why is that? Well, it's because the coefficient is greater than 1. It was greater than what we used previously. And before we technically did have a coefficient. The 1 was the coefficient, because the equation was y equals x plus 1. So really there was an invisible 1 here. So the coefficient was really 1. But because we used something greater than 1, it was steeper. And to help you understand this principle better, I'm going to do one more example, but I want to explain something else to you first. So there's a concept known as x-intercepts and y-intercepts. So what the x-intercept is where the line touches the graph, well, where the line touches the x-axis, and what the y-intercept is where the line touches the y-axis. So if you wanted to solve for that, right, so if I wanted to find out where the line touches the x-axis, what I would do is I'd actually set y equal to 0. And you'll see why I would do that soon. So I'm going to set y equals to 0. And then I'm going to do 2x minus 1. And now I'm going to solve for x. So I'm going to add 1 on both sides. These cancel out. And I'm going to get 2x equals 1. I swap sides, so just keep that in mind. That might have been a little confusing, but just know that I swapped the sides. And then finally, I would divide by 2 on both sides. And then this would give me x equals 1/2. And you could see, actually, if we were to go onto the graph, so this is what I got as my x-intercept. X equals 1/2. That's going to fall right here. And you'll actually notice that that is in between 0 and 1 on the x. So that actually makes a lot of sense because it's the halfway point. Now let's say I wanted to find the y-intercept. Well, what I would do is I would set x equal to 0. So when you look for an intercept, so like when you look for an x-intercept, you set the y equal to 0, and then when you look for a y-intercept, you set x equal to 0. So you kind of want to do like the opposite. Choose a different color for this. Choose this color. So I'm looking for the y-intercept now, so I'm going to set x equal to 0. So y equals 2, 0, minus 1. These are going to multiply and give me 0. Subtract by 1, and then finally I'm going to get -1. And if you look closely, that's what we had here. So this point is the y-intercept because this is where it touches the y-axis. So what I have, the point I marked in red, that's the x-intercept, and then the point I marked in this kind of like green color is the y-intercept. If you're a little confused when we solved for x earlier because it kind of seemed like the order of operations went in reverse, don't worry too much. I'm going to cover that in another video. But in case you already understood that principle, I just wanted to go over what the x and y intercepts are. So I'm going to go into one more example. I think this video is already getting pretty long, but I want to show you what happens if we were to use a fraction as the coefficient. So let's try something like y equals 1/2 x plus, I'll just do plus 1 again. I don't have too much room to work with here, so I don't want to make the constant too large. Now I want you to see very clearly what's happening here. So I'll use another color for a moment. I'll use orange. Now, if we were to do this, right? I want to take a look, especially what we have going on over here, because this can be confusing. What this means is it means 1/2 times x. So like, say if you were to put in a number for x, if you were to supplement a number for x. So let's just use 3 for an example right now. So we'll do like, and you were trying to put in your calculator or something. If you did 1 divided by 2 times 3, and you put that in, it's going to give you 1.5. And what that means is we're going to have to use something in between. We would sort of have to use something in between the lines, unless if we made our increments like fractional increments, which I don't really want to do. I don't feel like that happens a lot, so it's not really something that I want to do, but let's try putting in some values for x. So I'm going to mark the origin. That's right here, so that's the middle. And I'm going to put 0 in, so do y equals 1 over 2, and we'll put in 0 here, and then we'll add 1. So anything multiplied by 0 is 0, and basically like the process you'd use to multiply this would be like, 1, 2 multiplied by 0, and then it would turn into like 0 over 2, and then it would become 0. So that's going to be 0 plus 1, and finally that is going to give you 1. So for our graph here, I'm going to put 0 in down for x. I'm going to put a 1 down for y. And then we just go up on the y once because x is 0. We don't move on it. And this point is going to be 0, 1. Now, I'm going to do something, because of the way this works out, because of what I showed you before, I'm actually going to step it up a little bit. I'm going to try plugging in 2 for x. So let me do that. So y equals 1/2 times 2 plus 1. It's going to simplify to y equals 2 over 2 plus 1, and then that just turns into 1. So 1 plus 1, this is going to be 2. And we'll go over to our table over here. So we use 2 for the x this time, so the increment is going to be a little steeper, at least on the table. It's going to be, we're going to count by 2's instead of 1. So we'll put a 2 on the left, and we also got 2 for the y, in this case at least. So our coordinate here is +2, +2. So we take 2 steps to the right and 2 steps up. And this is going to yield 2, 2. And now we'll do, let's do 4. So let's keep going on this path of counting up by 2. So y equals 1 over 2, plug in 4 for x, and then add 1. Well, this will simplify to y equals 4 over 2 plus 1. This is just going to turn into 2, so 2 plus 1, and y equals 3. So, putting this down, we put a 4 in for the x, so I'll leave 4 here. And then we got a 3 for the y, so I'll put 3 there. And then I'll count 1, 2, 3, 4 to the right, and I'll count up by 3. 1, 2, 3. We'll stop here. And this is going to give 4, 3. They'll both be positive. And finally, I want to try using a negative number, because it is something that you will have to get used to. Just try -1. It might have even been better if I had just been writing them here first. It might have been less confusing. So I'll try to do that going forward. So y equals 1 over 2. Actually, no, I said we were counting by 2's. Do -2. So put a -2 down here. And then we substitute that in for x. And then we add 1. And then I put a -2 up here in the numerator, leave +2 in the denominator, add 1. This is going to turn into -1. Keep that in mind, because a negative number divided by a positive number is a negative number. So -1 plus 1. And then this gives 0. So we get 0 for the y. Let me count 2 steps to the left. So 1, 2. And then we don't move on the y, because y is 0. And then we get -2, 0. And then let's try drawing a line. So that looks like this now. Again, the line might not be perfect, but you could see. And if you look at this, you'll actually notice that it's more flat than what we had, because now we use the number less than 1 for the coefficient. We use 1/2. And fractions show up a lot when it comes to these linear equations. If the number in the numerator was greater, it would be steeper. And if the number in the numerator is greater than the denominator, then it will even be more steep than what we've drawn here, because then the number will be greater than 1. If the number in the numerator is greater than the number in the denominator, so the numerator in this case was this. Oh, I still have the line drawing tool active. The number in the numerator was this, and then the number in the denominator is here. So if that number in the numerator was greater up here, we would have had a line that was steeper than what we had first drawn over here. You know, I said that this would be the last example, but I want to just try to do something really quickly, because sometimes you will have a coefficient that's negative, and I think it's important to show you that as well. So let me show you that. So y, let's say negative 2x plus 1. So now we have a negative number for our coefficient, and I'll try to go over this a little faster. So we'll plug in 3 numbers. We'll start with 0. 0 is usually pretty easy. And I'll just draw the origin point here, just so we have it for reference. So y equals negative 2. Put 0 in here, add 1. Anything times 0 is 0. And then we add 1. We get positive 1. So our ordered pair is 0, 1. So we don't move on the x, we just go up 1 point on the y. This is 0, 1 right here. And we'll also just do 1. We'll do 1 for x. Y equals, so that would be negative 2 times 1 plus 1. Now, you have a negative number times a positive number. That is going to yield a negative number. So we get negative 2 plus 1. This is going to equal negative 1. And this point, so we have 1, negative 1. This is our ordered pair now. So that means we move right 1 step, and then we actually go down. So we land here. And this is our point. And our ordered pair is 1, negative 1. And we'll do one more. And in this case, what I want to do is I actually want to use a negative number for the x. So I'm going to use negative 1. So negative 1, then we solve for x. So negative 2. Well, we don't solve for x, actually. We solve for y. So we basically just simplify what's here. So we get negative 2, negative 1. We add 1. This simplifies to positive 2. And then we add 1. And this gives us 3. So we have negative 1 and positive 3. So then we take 1 step to the left, and then we actually go up 3 points. So 1 step to the left, 1, 2, 3. That's going to fall here. And our ordered pair is negative 1, 3. Now, I'm going to draw a line, and I'm going to connect these points. and you could see something a little unique, something we haven't really seen. The line is actually traveling in a different direction. And if we look at the others that we had, right, they all went up. From left to right, they were going up. But because we used a negative coefficient, now it's going from up to down, from left to right. So depending on whether the coefficient is positive or negative, that is going to affect the trajectory of the line that you draw. That is going to do it for this tutorial. I appreciate you sticking around for this long. I know it was quite long. Hopefully you learned something. Thank you very much for watching. I plan on creating an entire course for college algebra. So if you want to keep up with that, feel free to subscribe to my YouTube channel. And if you're looking for online tutoring, you can send me an email at fixingfoundationsfoundation@gmail.com. You can see that on the screen right here. Thanks again so much for watching, and I hope that we will both continue to grow as mathematicians.